Okay, we've already seen the geometric representation of lines and seen the idea of affine spaces, affine hull, affine sum, and convex hull. Now we look at what are called planes. And how do we represent planes? So a plane can be represented by either by a point and two vectors or by 3 points. So in a line, remember we had P of alpha as R plus alpha times D or alpha times V. But here we have two vectors. We have a point R plus alpha times U plus beta times V, or we can also represent using 3 points like R plus alpha times Q minus R plus beta times V minus R. So a plane is represented like this. Another a specific plane which we want to represent is a triangle. A point of a triangle can be specified by two coordinates. So if you have 2 points, first you find the parametric form of a line joining these 2 points by the convex sum of P and Q, using the similar to what we had for the line segment. Then you take that point, which is like a variable point between these lines, and take another point R and take the convex sum between S of alpha and R. So note that all alphas and betas will lie between 0 and 1, which means that it is a convex sum. So it's a convex sum, right? So it has to be, all the values have to be greater than 0 and all has to add up to 1. So if you take such a combination, you will get a triangle. Also, while we are dealing with planes, another important aspect of a plane is a normal, which gives the orientation of the plane. So every plane has a vector n, which is normal to it. So if you have two vectors on that particular plane, it is given by n is equal to u cross v as the corresponding. The cross product between two vectors on the plane will give the normal to that plane. The equation of the plane in terms of the point on the plane and the normal, I think it's given by r dot n is equal to d. Or there could be other representations. That's about geometry. Now we'll look at representations. Okay, as the next topic.